Maltose, also known as maltobiose or malt sugar, is a disaccharide formed from 2 units of glucose joined with an alpha bond, formed from a condensation reaction. The isomer isomaltose has 2 glucose molecules linked through an alpha bond. Maltose is the second member of an important biochemical series of glucose chains. Maltose is the disaccharide produced when amylase breaks down starch. It is found in germinating seeds as they break down the starch stores to use for food, which is why it was named after malt. It is also produced when glucose is caramelized. History: maltose was discovered by Irish chemist and brewer Cornelius O'Sullivan in 1872. Its name comes from malt, from Old English meal, of Germanic origin, and the suffix -ose, of suffix denoting names of sugars and other carbohydrates. Structure and nomenclature: maltose is a biomolecule that belongs to the group of carbohydrates within the division of biomolecules into the 3 main groups: carbohydrates, lipids, and proteins. Carbohydrates are composed of carbon, oxygen, and hydrogen COH and are either polyhydroxyaldehydes or polyhydroxyketones. As a group, they are generally divided into monosaccharides, oligosaccharides, and polysaccharides depending on the number of sugar subunits. Maltose is an oligosaccharide, specifically a disaccharide, formed by the union of 2 glucose units. Glucose is classified as a hexose because it is composed of 6 carbons. The 2 glucoses which compose maltose are cyclized in paran form and are joined by an aglycosidic bond through the first carbon of the first glucose and 4th carbon of the second glucose, indicated as. The link is characterized as alpha due to the aglycosidic bond to the anomeric carbon being in the opposite plane from the CH2OH substituent in the same ring. If the aglycosidic bond to the anomeric carbon was in the same plane as the CH2OH substituent, it would be classified as a beta bond, and the resulting molecule would be cellobiose. The anomeric carbon of the second glucose molecule, that is not involved in an aglycosidic bond, could be either an alpha or beta anomer depending on the bond direction of the attached hydroxyl group relative to the CH2OH substituent of the same ring, resulting in either alpha maltose or beta maltose. Due to a glycosidic link, maltose is a disaccharide that can reduce Fehling's reagent. Furthermore, maltose can be obtained by hydrolysis of glycogen or starch polymers of linked maltoses in position alpha and branching in position alpha. These are very abundant and form a large number of branches. Amylase enzymes produce maltose and limit dextrin. These can be further degraded by maltase enzyme to hydrolyze maltoses as glucoses, and they are ready to be degraded and obtain energy in form of ATP. An isomer of maltose is isomaltose. This is similar to maltose, but instead of bonds in position alpha, the linkage is formed in position alpha. Therefore, glycogen branching is defined by isomaltose. Maltose. Isomaltose is also a reducing sugar. Properties: maltose has the ability to reduce the Fehling's solution due to its free aldehyde. The aldehyde group is oxidized, giving a positive result, which means that the maltose is a reducing sugar. Maltose in aqueous solution exhibit mutarotation due to its anomeric carbon, which can form alpha and beta isomers. In aqueous solution, it is shown a balanced way between alpha and beta forms. It has a sweet taste. It is sometimes water-soluble and sometimes crystalline. Intolerance: homopolysaccharides of glucose have broken down by maltase and isomaltase to produce glucose. The lack of the sucrase isomaltase enzyme, one of the 4 integral glycoproteins, causes sucrose and maltose intolerance and is called congenital sucrase isomaltase deficiency. This congenital disorder is most prominent in infancy but can develop later in life. It is caused by a recessive autosomal mutation. Nonetheless, depending on the type of mutation, there are certain degrees of intolerance. According to this degree, physicians may decide the amount of starch the patient may have to remain healthy. This intolerance begins when infants begin to eat nutrients that contain starch, mainly containing maltose. One can notice that a patient suffers from this pathology when they have stomach cramps, bloating, excess gas production, nausea, vomiting and diarrhea. Upper respiratory tract and viral infections are common. These digestive problems can lead to lower than normal weight gain and growth. Possible associations are kidney stones and copper malabsorption. Quote, further studies have shown that certain patients with different degrees of mutation can actually improve throughout the years, reaching a maximum improvement at ages 3 years and 6 months.